Hello all. So in this lecture we'll see about characterizing schedules based on serializability. So in the previous lecture we have seen how to characterize schedules based on recoverability. So this is the outline of this lecture. We'll see serializable schedules, what is serial schedule and non-serial schedules, then what do you mean by result equivalent schedules and what is conflict equivalence. So, what are serializable schedules? So, serializable schedules are considered to be correct when concurrent transactions are executing. So, those serializable schedules are schedules which are always correct when concurrent transactions are executing. So, we'll see about the serializable schedule later. Before going into that serializable schedule, so we'll define what do you mean by serial schedules. So, serial schedules places simultaneous transactions in series. So, if we have two transactions T1 and T2, T1 will be executing first, and after completion of T1, T2 will be executing. Or T2 will be executing first, and after completing T2, T1 will be executed. Then those schedules are known as serial schedules. Okay, we will see an example. So we have two transactions T1 and T2. Here if you see this, all the operations in T1 are executed first. And after completing or aborting or committing this T1, then T2 starts executing. T2 will continuously execute, all the operations will be consecutively executed, and after completion of T2 it will be committed or aborted. So this will be always correct. There won't be any problem because there is no interleaving of these operations. And this is another serial schedule. So here T2 is executing first. After completion of T2, T1 will be starting and T1 will be completing to execution. After that only any other transaction can proceed. So this is these two are examples of serial schedules. So that is what we have written here. So places simultaneous transactions in series. If there are n number of transactions, number of transactions will be kept in series. Okay. And all other schedules are called non-serial schedules because if there are interleaving of operations, then they are known as non-serial schedules. So this is non-serial because there is interleaving of operations here. Here also there is interleaving of operations. So these are known as non-serial schedules. So schedule, formally we can say serial schedule. It is a schedule if for every transaction T participating in the schedule, all the operations of T are executed consecutively in the schedule. Otherwise, they are non-serial schedules. Okay. So there are some problem. We cannot always schedule like this. We cannot have serial schedules like this. There are some problems with this serial schedules. The first thing is it will limit concurrency by prohibiting interleaving of operations. So you have already learned in operating system, if we have a process that is being executed in the CPU, when that process has to do some IO operation, it will move out of the CPU and some other process will enter into the CPU. There will be interleaving. So that kind of interleaving won't be there in the case of transactions. So if T1 is being executed and in between T1 has to do some other work, T2 cannot come into the and come and use the database because we have already mentioned that T1 has to complete first, then only T2 should be executed. So it will limit the concurrency by prohibiting in interleaving of operations. Okay, and this is unacceptable in practice. So this cannot be this is not at all acceptable. We cannot have schedules like serial schedules. So solution is we have to determine which schedules are equivalent to a serial schedule and allow those schedules to occur. So this is a solution. So what we have to do is if we have some interleaved or non-serial schedules, if we have some non-serial schedules, we have to check whether those non-serial schedules are equivalent to serial schedule because serial schedules are always correct. So we have to check whether non-serial schedules are equivalent to serial schedules. If they are equivalent, we can say that this non-serial schedule is equivalent to this serial schedule. So in this example, if you see, these two schedules are always correct. There won't be any problem because they are executing one after the other. Now we have these two serial schedules, Schedule C and Schedule D. Now we have to check whether Schedule C is equivalent to any of these two schedules or Schedule D is equivalent to any of these two schedules. If they are equivalent, then we can say that uh, no, this is correct. This Schedule C is correct or Schedule D is correct. Okay. So serializable schedule. So we will define what is a serializable schedule here. A schedule S of n transactions is serializable if it is equivalent to some serial schedule of the same n transactions. So if there are n transactions and if there is some non-serial schedule, we have to check whether that non-serial schedule is equivalent to some serial schedule. But the problem here it is if there are n number of transactions, then there will be n factorial possible serial schedules of n transactions. And there will be many more possible non-serial schedules also. So it is very difficult to find out. Okay. So these are some examples of serial schedules and these are non-serial schedules. Now we have to check whether schedule C is equivalent to schedule A or B or schedule D is equivalent to schedule A or B. So for checking that, so we will take one example. In this case, we will take one example. Okay. Now we will give some example. So we will give x and y as 90. Initially let x and y be 90 in this case. X and y be 90 and let n be 3 and m be 5. N is 3 and m we have using m also. So m let it be 2. N equal to 3 and m equal to 2. So after executing T1 and T2, what will be the result? So we have to check what will be the result after being executed. So I'll take the pen out. Okay. So what we are doing is we will give some value. So x was initially we have mentioned that x is 90. It is very difficult. Let it be. Okay. Okay, so x will be 90 and n is 3. So 90 minus 3 we will get as 87. Then we'll be writing x. So x will be 87. Then after that we are reading y. Y is 90. Then we are adding uh, n again. So n is 3 we have already mentioned. So 90 plus 3 it will be 93 and we are writing y. So y will be 93. Then so x will be 92 and y will be 93. Sorry, x will be x minus n is performed. So x minus n is 87. Sorry, 90 minus 3 it will be 87 and y here y plus n is done. So 93. Then after that we are reading x again. So x what will be x now? X will be 87. So we have updated it. So x will be 87. Then after that we are adding 3 to it x plus 2. So 87 plus 2 it is 89. So x will be 89. So finally after completing of this execution x will be x will be 89 and y will be 93. So we have to check whether x will be 89 x is 89 or y equal to 93 in any of these two schedules. So we will check. So if we give the same values here, x is 90, then 90 minus 3, it is 87. Now again here we are reading x again. So x will be 87 here and 87 plus 2 will be done. X becomes 89. Okay, now we are writing it. So x 89 will be written 89 will be written. After that, we are reading item y. We are reading this item y. Our y is 90. We are writing x again. So x will be 89. Okay, it will be 89. Now we are adding this y plus n, so it is 90 plus 3, it will be 93, and we are writing y again, so it will be 93 will be written. Okay, so now the final value of x will be, so here x will be x minus n, it will be 90 minus 3, 92, and we are reading it, so 92 plus x minus n, sorry, x will be 90 and n 93, sorry, 90 minus 3, it is 87, 87 plus 2 will be done. Now schedule C, after executing schedule C, it will be x will be 92 and y will be 93. Here x will be a problem. X should have been actually 89. Here after performing all these operations, what we get is x will be an error result will be there. So one, we have already seen this lost update problem is there. One of the updates will be lost here. Here there was mistake when we calculated, because x was 90 here, 90 minus n, it will be 87. After that we are reading x. Before writing this x, we are reading it again. So x will be the previous original value that will be read. Here it will be 90 again, and here 90 plus 2 will be done. 92 will be there. Then we are writing x. So 92 will be written, and y again 90. Then we are again writing x. We will be writing 92. Then we are adding this y plus 3. It will be 93, and we are writing y. We will get 93. So x will be 92 and y will be 93. So actual result should be x should be 87 and y, sorry, x should be 89 and y should be 93. But we are getting incorrect result for x in this schedule. Now we will consider this case. What happens in this schedule? So initially x is 90. So 90, 90 minus 3, n is 3. So 90 minus 3, it is 87. We are writing is so we will be writing 87. After that we are reading x. So since we have written it, so we will be getting the updated value here. X will be 87. Then 87 plus m. 87 plus m means 87 plus 2, it is 89. We are writing it after that. So it will be 89 will be written. After that we are reading y. Y is 90. 90 plus 2, 92 will be done, and 92 will be written. So finally x is 89 and y is 93. So schedule D is correct. Schedule D is equivalent to this schedule or this schedule. So schedule D is considered to be correct, whereas schedule C, it is incorrect because this update is missed here. This update is missed here because we have already seen there is lost update problem. This updation is not reflected here, because when before writing this x, we are reading this element. So that lost update problem is there. So schedule C is incorrect, but schedule D is correct. So these schedules, this schedule D is known as result equivalent schedule, because the final result is equivalent to that serial schedule. So if they produce the same final state of the database, then we call it as result equivalent schedules. So schedule D is a result equivalent schedule. Schedule D is a result equivalent schedule because the final output is the same as that of some serial schedule. So it is a result equivalent to that serial schedule. But the problem with this result equivalent schedule is it may be accidental. It may be an accidental cases can occur in this kind of schedule. So if we say so it cannot be used alone to define equivalent schedule. I'll show one example why we say that result equivalent may not be correct. For example, if we have two schedules S1 and S2, the operations in S1 and S2 are like this. Let the initial value of x be 100 here. So we are doing 100 plus 10, it will be 110, and we are writing it into the memory, we will get 110. And we have another schedule which has a different set of operations. We are reading 100 again here, 100 into 1.1, it is again 110, and we are writing x. So it will be 110. But we cannot say S1 and S2 are equivalent, even though the result is same. But we cannot say it is result equivalent because the operations are different. So that is why we say it may be accidental. In some other value, if we are giving 90 here also if we are giving 90, then 90 plus 10 will be 110, sorry, 100. And here 90 into 1.1 is never 100. It is not 100. So we won't get the correct result here. We won't get the correct result here. Okay. So for some values it may be correct and for some other values it may not be correct. So it may be, that is why we say result equivalence may be accidental. So result equivalence schedules cannot be considered for serializability. Okay. So for that, what we do is we have conflict equivalence. So we will define some other way to serialize these schedules. Okay, conflict equivalence. So two schedules are set to conflict equivalent if two schedules are set to conflict equivalent if the relative order of any two conflicting operations is the same in both schedules. Okay, then we can say that it is conflict equivalent. So what we are trying to do is we are trying to find out whether schedule C or schedule D can be considered equivalent to schedule A or B. So one way is using result we can compare. Using results we can compare with the serial schedule. And if we say the result is same, then those are same. But it is not correct. We have already seen this example. It may not be correct for all the values of x. Here we have seen x for 100 it is correct, but for some other value it may not be correct. So it may be accidental. So there is another way to see whether to show this equivalency, that is conflict equivalence. Here what we do is we consider two schedules are said to be conflict equivalent if the relative ordering of any two conflicting operations is the same in both schedules. So that is what we will see. So two operations conflict. We have already seen what we mean by conflict operations. Two operations conflict if they belong to two different transactions, access the same database item, and either both are write operations or one is a write item and the other is a read item. So we have already seen two operations are conflicting if they belong to two different transactions, they access the same data item and one is write, or sorry, both are write or one is write and the other is a read item. Okay. So in this example, we know which are conflicting operations. Here, x is read here, and here write x is there, or here read x is there, here write x is there. They both belong to different transactions. They are accessing the same x value, and one is read and one is write. Okay, and this write x and this write x are conflicting because they belong to two different transactions. They access the same x element and both are write operations. So these two are conflicting operations. So we have already seen. So now how to define serializable schedules based on this conflict equivalence. So schedule S is serializable if it is conflict equivalent to some serial schedule S dash. So if schedule S is serializable if it is conflict equivalent to some serial schedule. So previously we have seen result equivalence. So we have already seen it won't work all the time. So another way is we will check whether they are conflict equivalent to some serial schedule S dash. So if in this example, schedule A, we will take the example of schedule A and schedule D. They are conflict equivalent. Okay, they are conflict equivalent. So what is conflict equivalent? So if the this schedule A we have already seen, this is a serial schedule and schedule D is a non-serial schedule. So this is equivalent to this serial schedule. How we can say is that we have to check the conflict operations in these two schedules. So here the conflicting operation, we will check from this schedule D, the conflicting operation is here if we check there is a write item and a read item. So these two operations are conflicting. Now what we have to check is whether this conflicting operation order is the same in the serial schedule. So here first T1 we have write X, then after that T2 read X. Now we have to check whether in T1 write item of X and after that it is read item of X. So this conflict is okay. Then after that another conflict is write item of X, then there is no other conflict because we are reading a different item, so there is no other conflict. So the conflict here is being resolved here. So we can say that schedule D is equivalent to schedule A. Schedule D is equivalent to schedule A. So if we take the previous example, in this example, if we say schedule C is not, we have to check the conflicting operations. Here read, here again read, then after that read, we are getting a write here. So there is a conflict here, read and write. So T2's read, and after that we have to check whether T1's write is coming. So if we check, this is not equivalent. Okay, then here also it is not correct. Okay, so we cannot say this schedule C is not equivalent to serial schedule A or B. So that is conflict equivalent schedule. So serializable schedule, schedule S is serializable if it is conflict equivalent to some serial schedule S dash. So schedule A, so schedule D is conflict equivalent to schedule A because whatever conflict of operations are there, they are coming in the same order here also in schedule A also. So then there is no problem with this. So we'll get the same result or it is equivalent to this serial schedule. Now we will see how to check this conflict equivalency in the next session. How to test whether it is conflict equivalent in the next session. So this is a reference. Thank you.